Okay, so like I said, we're just gonna create some, I don't know what that is. So that's from our previous exercise. Let's just clean up some of this stuff. Okay, so we have our surface here. Like I said, this is gonna be your, this is gonna be when you actually create your soil profile areas. So I'm just gonna imagine that I'm going through the same exact process. So I'm gonna create a new layer and type soil survey. And then I'm going to create a sublayer and call this soil class A and just create another soil class B. Even though we're only looking at one soil classification for this, I'm going to draw two classifications so you could see like, okay, we looked at this soil group, now let's look at this soil group. Makes it pretty, and I'll show you how easy it is to do that. But also simplify it at the same time. So let's give these some slightly different colors. Hopefully I don't choose any rival colors that you guys would hate me for, so I'm gonna avoid other SEC colors. Okay, so let's choose this, and I'm just gonna draw a real kind of figurative landform, but have it at least do enough to know that it's gonna cover it. So let's just change that to wireframe so I can actually see where that is. And now I'm going to draw another classification. Why is mine? So there you go, these wonderful soil profiles. That should be it that we have to do for Rhino. Obviously, the stuff that Val and I had initially come up, we could even start to classify where existing plant types are, so you trace that out. And the point is it can be very complex, but hopefully this is enough to just help you guys start out with understanding how it can all be processed. So I am going to go ahead and select both curves. So I've got those two curves selected. I'm going to keep this one open because the aspect is a real pain, so I might have to most likely refer back to that. So what we want to do is reference both of these curves. So I'm going to bring in the curve component, right click and say set multiple curves. And what we want to do now is I'm going to turn this off, and this is where you get to start to kind of filter out that information. So even though both are in here, I can create a little function to highlight one or the other. So I'm going to go over to sets. I know we haven't done much in this area, and there's kind of a reason because this is where it gets really muddy sometimes. But I'm going to use this list item component and drag it into there. And this gives you the option to switch between objects. So I'm just going to create a number slider. I'm just going to hit 1, and that way I know I have either 0 or 1. There's only two soil types in this, so that's why I only have 2 values. If I had a third one, I could then do 0, 1, and 2. But the point of this is that I can drag that into there, I can highlight it, and I can see I can see that this one is highlighted green. If I drag it to the next one, it switches soil groups. So this helps you begin that process of, okay, which soil or which points in my model are confined within these curves. Having closed curves is really important because that's the first way of actually separating information, is that you need a closed curved object. Okay. And what's good about this is that you actually don't even have to, you can see that these are actually drawn on the ground plane. If you wanted to, you could project them onto this, or you could keep them flat. It really doesn't matter because what we're about to do next is going to just understand it from like a projection. So you'll see, I promise. So what we need to do now is essentially, like we did before, begin to divide our surface out into a set of grid points. This is what we're going to filter out. So I'm going to take that surface and reference it again. Let's go ahead and let's just keep this on, but I'll turn this off because the clay model looks kind of cool. We're going to take that and we're going to divide it. So surface, divide surface, and I'm going to, again, make it fairly dense so we get a good aggregate of information. Obviously, if we wanted to really kind of optimize it, you can really densify it, but just realize that's more information to process. Okay, so we got pretty good series of points. So the first step, like I said, that we want to do is figure out which points are in which curve. So you can kind of see them there. If I change this color, this might help too. Nope, not really. You can kind of see them still there. Let's turn off the grid at least. You can kind of see them. It's a little hard to see that other one, but it's there. And so the function we're going to use now is in our curve tab. Again, we're analyzing these points. So we're doing point in curve. If I had multiple closed curves of one soil classification, so if there was 2 closed curves of soil class A, I would do point in curves. In this case, there's only one. However, it doesn't hurt it if you use this one. So I'm still going to use that in case I decide to like add another soil profile. So I'm going to drag this into there. And again, we're going to flatten these points for now. And you can see that it doesn't really do anything, but it does, I promise. So what you'll see that's coming out of this is ignore the null parts. Those are just like those points that are making up the part of that surface that we traced away. But the important thing that's coming out of this is you'll see that point region relationship. If it has a 0, it means those points are outside the curve. If it has a 1 value, that means the points are right on the curve, which is pretty rare. But the important thing is 2 equals inside. So if any of these points have a value of 2, that means they're inside that curve. So if I were to drag this out, like I said, there's some nulls which are annoying to deal with. We'll filter that out. You'll see there's a lot of zeros, a lot of zeros. Oh, I saw some 2s right there. So you can start to see that there are points in that curves like we kind of figured. I would hope so, else we'd be in some serious trouble. I don't know if there's going to be any 1s. That's fine because we can even include those. But the first thing we want to do is deal with these pesky nulls. They're essentially just missing data, and it can really screw with some things, but we could also get rid of those. So I'm going to go to my list, and you'll see that there's this component called Null Item. So what it's going to do, it's going to look at this data. And then it's going to tell me, it's going to give me this Boolean that says, or it's a pattern. So if it's null, it means true. If it's not null, so if it has that 0, 1, or 2 value, it's going to read as false. I really just want to kind of separate those null values. So it creates this cool pattern that's useful for this dispatch component. So what it's going to do is ask for a list. So this is these values, all these either null, 0, 1, or 2 values. It's going to use this pattern of true and false Booleans to determine if it's in. So you can see this is now only going to contain null items, And this is going to contain all those numeric values. So I can even just clarify that real quick so you can see here's all those annoying nulls, and here's all my numeric values. So it's kind of just, it's a little bit of extra work, but it helps us just focus on these values. And for this, I'm also going to apply the same pattern for my points. So again, I know some of this is very foreign to you, so don't freak out too much. Oops, let's not disable that. So again, we're sticking with, in this case, our B values, so that's our points, and that correlation of either 0, 1, or 2. So we have to essentially find all those points that have a 1 or a 2 value. So we're going to go to Math, we're going to choose Operations, and we're going to do larger than. So we're basically going to take these values of 0, 1, and 2 and determine if they are greater than or equal to 1. We're choosing 1 because we want to include those points that just so happen to be coincident with that curve. And that again is going to create us this weird true and false dispatch pattern. And so I could even just relabel these as point and curve values. Like what's cool is you can actually start to rename some of these to help understand, and these can just be point grid. Just so I know that one is talking about points, one's talking about their numeric value. And so now again, I'm going to run this dispatch component. And I'm going to look for those points that are greater than or equal to 1. And it's not going to show a whole lot because it's looking at both patterns. And we're also going to turn off this stuff so when we look at it a little bit better, we can understand it. And again, I'm looking for value A. And now you can see there's all those points that are in that curve. If I were to switch curves, now I've got those points. A lot of work for somewhat menial results, but it's pretty powerful at the same time. So as you draw curves or reference, you can start to switch from one soil profile to the next and have it already isolated to that soil profile. So that's the first phase of this.
Yeah, really complicated soil map.
Yes. So yeah, like rarely, like I said, you aren't gonna find a soil survey that has 2 soil classifications. So, however, you can usually find that data and bring it in, separated into those soil classifications. So then you just have to reference them in Rhino going through this process.
Are you looking for a particular file type? Are you looking for data, or is it, or could it be anything that you like trace?
It really depends. Sometimes you're looking for like CSV files, so just comma separated. You could use Excel files. You can even bring in shape files from Web Soil Survey using some of those plugins. Okay, so now we've got it. Oops. And what's cool is, like I said, like these curves are down here, but it's still understanding that technically those points are within that curve. So it's still referencing the points on the surface, not actually down there. Okay, so what's the next classification we have to filter these by? Aspect, right? So we're gonna do a similar thing with the slope, where we have to find out essentially the angle of these surfaces, But instead of figuring out their slope percentage, we're figuring out where are they pointing at. So we can do a fun little operation to determine that. It wasn't so much fun when I was trying to figure it out, but now I like it. Okay, so like we did before, we're going to, instead of just look at these points as freestanding coordinates, we're gonna find their actual normal direction. So the best way to do that is to, again, go to our surface, and we're really evaluating the surface. We're not technically looking at the points, we're looking at the surface of where those points are. So I'm gonna, again, use my surface. This is our major piece right there. Again, I'm looking for the UV point. I just have points so far. So I have to go through that process again of doing surface closest point. So it's looking for the point, and it needs that surface again. And now I've got my UV point. Now each one of those has its fun little direction that it's pointing towards, so that normal. This is where it gets to be really, really tricky. So you have to kind of, I wouldn't say lie to Grasshopper, but change its way of thinking. So in order to like filter, because like it's kind of like the pain in the ass one, because we're technically going from 315 to 0 to 45, we're having to like tell Grasshopper like, so instead of, like, we understand that we're looking for this kind of weird wedge that goes in both directions. Grasshopper is obviously just, it's looking at it as this, so north is 0, 90, 180, 270. So what we have to do in order to like use this 90 wedge, because it's still just that 90-degree difference, we have to rotate its coordinate system by 45 degrees. So now when we look at it and compare, we're really looking at it so like it's kind of weird, but I think you guys can kind of understand the logic. That way we're looking really for, we're really looking for angles that are between 0 and 90 degrees and not 315 to 45, because that's just an impossible logic to figure out for these things. So that's what I was saying is a real kind of pain in the ass to figure that out. But through countless nights, I finally figured it out. But I don't remember off the top of my head, so that's why we're gonna pull some information from here. So this is pretty much where we're at right now. We've evaluated that surface to find those normals, and this is where we're going to find the angle between whatever they're facing and the world axis. So we're going to, because I don't want to recreate this, I'm just going to copy that from this script. I'm going to go to this one. I should probably save this in case I do something stupid and crash it. Vegetation, spaghetti sauce. Okay, so I'm going to go ahead and just paste that in here. So like I said, I've got my normals. I'm going to measure them. And so what I did is, you can see I've taken that angle and I've rotated it 45 degrees to kind of reorientate how it's measuring these angles, okay? So I'm still just, this just helps us understand we're rotating on the XY plane. You have to get as specific as that because it doesn't understand if you're looking at it from the top to the sides or the other direction. So you give it that XY plane to orientate around, and now you've shifted it. These are just kind of like, it needs to know the vector to rotate. It needs to know the axes, and then you tell it to rotate by 45 degrees. And so now this is officially given all these angles their appropriate measure. So instead of looking for angles that are between 315 and 45, we're looking for 0 to 90, right? So this one's pretty easy because we could use a similar function to just look for degrees between 0 and 90 like this. So you can see I just simply do that. I guess these are being projected. I should probably, let's just stay with this whole mess. So like we did before, these are coming out in radians. So we have to convert that to degrees. So it's weird, even though we've rotated it in degrees, it still gives us radians, which is kind of weird. But anyway, so now we have degrees. So you can see, hopefully, if it's all correct, there's nothing that goes beyond 360. If I were to just do math, because we're still not, we haven't filtered out the 90, 0 to 90. So, I mean, that's pretty good, like almost 0 degrees to 359.59. It covers pretty much the entire spectrum. And we don't have anything beyond 360, so that means we're doing something right. Okay, so like I said, it's easier to do it for the north-facing one, even though it seems kind of hard. It's not until you get into like past that where you have to create this crazy function that says find the values between different things. So it's like easier to just kind of like chop away at that. But if you have to find values somewhere in between, you have to say find a value that's when your degrees is greater than y or 90, or degrees or equal to or greater than 90, but less than 180 degrees. You have to create this kind of crazy evaluation function to do that, which I'll bring that in just so you can do the full aspect of it. But that's why I like this, because I can rate just this part. Does that make sense? Like if I were to look for those other aspects, I can't just be like, find degrees that are less than 180, right? Because I've got all those from 0 to 90. So you have to kind of create that weird function. That's another thing I had to look up. So anyway, so let's go ahead and start to isolate those 90 degrees or more. So we're actually, in this case, looking for smaller than. So we're looking at angles that are smaller than or equal to what? 90, right? Technically, you could do 0 to 89 because 0 counts as a degree. It's one of those things like, if you're that worried about the precision of it, it's probably not going to make a difference anyway, because it's all just a computer simulation. But for the sake of just precision, we'll do 89. Okay, so now we have any values that are less than or equal to 89. And we can see that we've got about 227 that are, and 220 are, they're both going to have the same amount. But let's see how many are actually in that direction. So again, we're going to use our favorite tool right now, the dispatch, because we've got our true and false patterns. But now the list we're looking for are the actual points. So again, remember that we're continuously filtering down our grid of points. So now we're going to take our points here and drag that into our list. And now we'll see how many are in that. So we've got 28 points now that are within that aspect or orientation, or we have almost 200 that aren't. So again, I'll turn this bad boy off, go over to my points, and now we've got this isolation of points. So it's obviously not as simple as that. You can see why it's kind of valuable to do this because it's not a very kind of straightforward process. So now we've got these points left that are facing in the north direction, that are within that soil profile. Again, like, we're not messing with a whole lot of data right now. So I bet you I can even just shift to the other soil profile without it giving me too much of a headache, but I'm gonna save it just in case. Let's save this file too. Oh, perfect. So there's those soil types that are in that direction. Pretty cool. All right, so let's do the final thing. We probably have more time to add even more kind of crazy stuff to this. So then we can even start to like add elevation or whatnot. So that's where I ask you to hit me with your best shot on this. Anyways, okay. So let's show, like I said, like this is really just filtering out that very specific degrees. So we're only looking at the north, but if we want that ability to look at other aspects, I want to provide that for you as well. So again, like it's not that I don't know how it works. It's just like, again, like it's very precise. Like if you have any missing information, it's going to ding you. So I'm just going to copy that. And you can see like, so this one is for 89 to 90. So I guess would be 90 to 179. Then we go up to that another set of degrees. Then we go to that final one. I think I can come up with an interesting way to do this actually. Okay, so we got our little equation here. So again, we could do the same thing probably. So if I were to do, we could write a fun little prescript or a fun little expression here, actually. Let's see if it works. So I'm going to, that way this could actually serve as like your ultimate aspect classification. So the first thing it's asking for is that variable in X. So that's still here. It's the same thing that we're plugging in there. But we needed to know between a 90-degree angle, right? So 0 to 89, 90 to 179, blah, 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 so forth and so on. So I could do something where I could do, what's the lowest limit of the highest degree? So 269, I guess. I'll do something even cooler. So I'll help you guys out with this. So we're going to do 0. Just to start off, I'm going to right click on this, say multi-line. And so 0. So we do 0 to 89, 90 to 180, or 179, 180, oops, 180, 70. Yeah, that's right. Okay, so we're going to do something very similar like we did before. Is anyone able to actually follow along, or is it just, well, I mean, actually like on the, okay. So what we're going to do is kind of like how we did before. It's going to give us a really simple application to classify this. I have 4 values in this case, so I can just use 0 less than 3. So what's great about this is that I can just drag like, okay, I know my first value here represents my north facing, then I've got my east facing, west facing, west facing. So I just start off with these values in my y direction. So you also need to give it that high value, right? So we need, let's drop it down to 0. So there's 0 that's going into there. What's the high extent of this? 89, right? So I can actually drag this into here. So it's kind of looking at 0 to 0. But if I right click on this and give it, oh darn, so I can't give it an expression there, but I could just simply say, you know what, take this value, so we have 0, and let's just add, because we're going to be adding 89 to each value. So now we're getting, by just changing one slider, I'm looking at 0 to 89. When I switch it, then I'm looking at 90 to 179, 180 to 269, 270 to 359. So that's cool. Let's see why that's still reading as red. I've had this issue before, so. I might have to. Interesting. Did I filter anything out of this? I'm pretty sure there's definitely values in between that. This gets very kind of finicky sometimes, unfortunately. Let's try, what if, oh, I think I know why. Darn. I bet you if I just drag this into here, so I'm gonna be really bummed if this works. Yeah. So the way this evaluation works, it only likes to deal with sliders, not these like list items. I guess like, I hate to do it that way. Yeah. That's what I'm thinking. I could technically do it. So actually, what if I did it? Instead of doing this, I could do, so you can actually just like insert sliders also. So let's see if this fixes it. So I'm gonna literally, since for whatever reason, it only likes sliders and not the burgers, but.
I was waiting for that.
I always deliver. So I can actually select not that. I can drag multiple sliders by holding Shift. If I do them in the right order, it should read them right. Let's see if it still likes this way. And then, oh, it's gray. Woohoo. Problem solved. So this is giving us, again, a true false. So the logic still works, right? I've got, in this case, I've got 0 to 89 that I'm looking at, 90 to 179, 180 to 269. So it's still working, and now we've got a gray one. And it's giving us a pattern. Instead of true and false, it gives us 0, 1s, which are the same thing. And now we can say goodbye. And we don't need this one. So voila, this is the beauty of just kind of really kind of working out the details. Uh-huh.
So this little package down here
Uh-huh.
is all about helping us figure out which aspect. Is there a way in Grasshopper that you can put a box around something, like put a post-it, like a sticky note or something that says, this is what this part of the script.
Yeah.
This,
I should probably do a better job of organizing that. So what I'm going to do for you then is say like, okay, let's give us some room because we definitely have time to do this unless you guys are that eager to get out. So I could double click and I can just give like a label. So I could say ref surface. So I'll use that as a way to label things. And then I'll even select both of those and hit Control G to highlight that area. So you know, like, okay, I'm going to make sure that goes there. I'm going to do the same thing for here. Soil curves. Is this what you're referring to?
exactly.
That way, like, you know what to deal with. Sweet. So this could be even better. So I will call, like, I mean, you can call all sorts of different parts, but let's call this area, and like, just to kind of even help out even more, we're going to call soil points. And I'm going to, again, just highlight those, hit Control G, and then within that, I'm going to hit Control G here. I can, let's see if I can, let's give that even, you can even change the color for these. So yeah, let's make soil look kind of brownish. All right. So now you know, like, so what's good about this is so now you can be like, oh, what if I just want to look at all the soils or the points that are in that soil? So that's why I just kind of highlight that as well. And now, so here's just to kind of check if I'm competent enough or not. So we've still got that old formula of saying find those values between 89 and 0. I've got it set up the same way to look for 0 and 89. So let's see what happens. Like, keep your eye on this. Let's see if any of those points change. Sweet. So that means it's working, supposedly. So just like how we had the ability to change our soil profile, so now we're looking at the other soil profile and which ones are facing north. So that doesn't seem right. Those definitely seem like they're facing the other way, but it could be just very high detail. Yeah, because that almost seems like, am I doing it the right? Yeah. There might be something where I have to reverse. Oh. Remember how they're facing like in the wrong direction? Good thing we just kind of verified that. But again, like I can show you why that I hope that's the reason it's not working. Remember when we did that and we saw that they're all kind of pointing down? I'm assuming that's why it's messing it up, but that's easy enough to solve here. Oh, bam, there we go. So now those look like they're facing the right direction.
So if you ever made a surface and somehow if everything was facing the right direction, you would just reverse.
Exactly. So that's why I always check after I evaluate it to see if it's actually orientated in the right direction. Another way, like this is, I probably should have just done it this way. You can check it in Rhino by selecting your surface type dir for direction, you can see it's pointing down, right? So if I were to reverse that, I can flip it and say, okay, point up. But now it's going back to that old pattern, so I can get rid of this reverse component. Now we're back to
Because you put the direction.
exactly. So I probably should have done that in the first place, but you can see this looks about right. Like that's definitely facing north, just based off of the shading of this. And I'm in 3D, you might as well look at it three-dimensional, right? Like that looks, those look like they're facing north, right?
Mm-hmm.
I'll buy that. Okay, so like we did before, so we can look at the different soil classifications. So this one has even less now, which it is what it is. But now you're like, okay, what if I want to look at the other direction? So all I have to do is change, okay, let's look at, these ones are facing east. That looks about right, because it is kind of sloping downward, right?
So that's going to go down 0, 90, 180.
Yep. So again, I'll keep these here just so you can see. And then we got our north facing or south facing. So then if you want to look at direct sunlight, you select these ones. Pretty cool. My students are going to be.
Subdivide like northwest, southeast. Would you just?
Yeah.
I'm not asking you to. I'm just like theoretically.
So yeah, then you just 0, 45, 90. You would just keep doing it. So yeah, like there's obviously like you can narrow it down to the first degree, but I don't know if that's going to be very valuable. So yeah, you can always improve the resolution of that detail, which is pretty cool. All right, so now we got the easy part. I think that's probably the hardest part, is just doing that and understanding how it all works and making sure that evaluation functions. So again, so this is, so I'll be even better for this. I'm gonna write, so slope aspect 1 equals north, 2, or wait, I guess it's 0 equals north. 1 equals east, 2 equals south, 3 equals west. Oops, not 3 plus. That way you have kind of just a reminder of what these slider values work. The really unfair thing to this is now, like, you literally just have to plug in your surface and you've done this amazing analysis, but then Valerie realizes how easy that was and it's going to ask even more of you. So sorry, not sorry. Exactly. Okay, so this could be our, so let's highlight this first. Let's make this yellow for sun. All right. And then this can be our aspect points. Okay, so we're getting there, right? So we're really kind of aggregating this down. And then the last one we need to do, so it's really not even that complex of a script. It's getting really easy. You laugh, but we could be somewhere like this. So let's, and it looks kind of cool. Okay, so what's the last one we need to do? Or at least the next one. We're really ahead of schedule. What do we want to know now? Yeah, so now we want to look at the proximity of our major drainage patterns. So this is going to be a cool, unique one too that we haven't looked at much yet. And this could get a little misleading because it's really going to depend on the resolution of the drainage. Like you could almost populate this entire thing with drainage lines, right? So technically all of them are going to be close to moisture. So you kind of want to do something a little bit of a lower resolution so we can really kind of determine more defined curves. I mean, we'll see. I haven't gotten to this point yet, but that's the fun part of discovery. Okay, so we're going to now take our surface and use the Sonic plugin or the Mosquito. So we got our surface. I'm going to drag this all the way over here and move this stuff out of the way. We're going to divide our surface. I got to go back over there. So now we got a grid of drainage points. Now we can do, let's just give us a 15 value so we can always change it. Flatten, drag that to there. Now we get a decent resolution. I think 5 worked pretty well earlier. And then we want maybe like 50 less than 300. Let's give it a shot. So there's our drainage lines. I'm wondering if there's a bet. Could we aggregate? I'm gonna look at this a little bit different so I can see. Okay, and then we don't need this anymore. So now we can see, like I said, it kind of could it cheats it a little bit because if we increase our resolution, almost everything looks for it. Like you can really obviously make this pretty dense. But there's still something being understood from this. Because you can see these points are kind of at the headwaters, like the water's clearly draining away from there. These ones are a little bit closer. Like you can that's a really dense point, but looks pretty awesome. But you can see like these are definitely away from that. So something you could do, let's see, like those are definitely at the headwaters. Those get a little bit closer. Let's save it. But like, for example, here too, like there's clearly a congregation of water there, or confluence. There's some confluence of water there and there. So what we can do, I mean, you could really, even though it's dense and a lot seem close to these curves, it's not really so much the start of the curves, right? It's where the end of those curves are, where the water is collecting. And so I could do something where I look at actually, instead of using this, I've got a better idea. So instead of looking like we really don't need this information, right? For the most part, I don't know. Yeah, I'm thinking because it's like, so what I'm seeing as an opportunity, it's like, we really only need the curves that are within our soil group. But sometimes water's flowing from outside our soil group into our soil group, so we can't just isolate it to that area. It's kind of like with site design, right? Like off-site water is flowing into our site, our site water is flowing off-site, so let's just keep it as is, actually. Like, we've only got almost 6,000 curves. It should be okay. And we can even increase their length. It's probably really not going to like that, but I just saved, so. So we could do so like what we could do for this part actually, let's not just declassify the points that are away from the bottom of these drainage. Let's do something where we classify, you know what, like if they're within 5 or 10 feet, it's a bright green to show that it's growing. If it goes from further than that, then it becomes yellow and then red. So it kind of gives almost like a drought gradient, or
Like a soil moisture.
yeah, like a soil moisture. Like that, I think be more beneficial than just figure out like, okay, where
Or just getting rid of them.
yeah.
Yeah.
Let's try that.
Because plants grow along gradients. And
Right.
It's not like a seed only
Yeah.
on land, just one particular condition because it died off.
Exactly. So that could be a good way. So you could almost say like, that's again where we're doing some really cool stuff. Oh, there's still that road curve. Okay.
Could you also use like height and color, right?
Oh yeah, that's what I'm thinking. Like,
Yeah.
we still got like 30 minutes and we're about to conclude this. So. Okay, so because this is just getting wicked awesome. So, like I said, like it's important to know where the headwater is versus where it's draining. I'm just gonna, for the sake of not overwhelming my computer, I'm gonna drop that down. It's really about the length too. And it should be okay with this. Like they're almost collecting all in the same point and aren't moving a whole lot further away. I feel like they're all kind of reaching the extent of their drainage and then they're just getting all wobbly. So this is the cool part. So what do you think the operation we should use to determine if these points are close to the end of the drainage line? Have we done anything yet to figure that out? Say what are you? No. Or what was like the, closest point? Is that what you said? Yeah, closest point, right? So we can figure out like the point for all these curves with these remaining points to figure out like which ones are closest, which ones are furthest away. And that way we can use that distance value to give us our color gradient. So let's go ahead. This is what we were playing with earlier. So you could almost do it this way. Would actually be cool because we're going to use this curve or this component to determine the endpoint. But if you shift it, don't worry about that. If you shift it halfway, then it's going to classify like the ones that are halfway through this curve that get like 50% moisture, so to speak, are going to be your location for your optimal plants. And then the headwaters are going to have their green. So that color gradient is actually going to change based off of where we have this. So the reason it's red, so don't freak out, is that there's probably just a curve that's not being created. It's still working. It's just very slow. So I'm going to just, again, reduce some of this data. This is going to be really gnarly now that I think about it. Let's drop that down to like 50. I don't think there's a whole lot that changed. Yeah, and that helps it read it a little better too. Oh, I wish these were. What if I change this resolution real quick too? It's not, again, like we aren't studying the drainage patterns for the drainage patterns. We're studying them for their proximity. So they don't need to be of the highest resolution as long as they create a general direction. Man, this is really not liking this. I'm going to stop fussing with this. Okay, so we've got, and we're going to shift this to the back so that read a little bit quicker. So we have here are the edges of our drainage patterns. So we're going to measure where these points are in relation to the other ones. So whichever one's closest is going to read it first and then have them all kind of end. So we got those. So I'm just going to go ahead and turn that off since we know it's in the right spot. I'm going to go over to my vector and use the closest point. And again, the headwaters is what we want to measure from. So that becomes our cloud point. This becomes this point.
You're measuring from the low point, not the top.
Yeah, so I'm at, yeah, sorry, so the low point of these drainage lines. Again, I'll run that operation for you guys to see how this is actually working. So here's all our vegetation classifications. So that's what we're really looking at in the relationship to the moisture level. And this is determining, so you can see these ones are pretty far away versus these ones are a little bit closer. Same with these ones, you can see that's where all the water's collecting and that's what's kind of creating this little kind of ravine or ditch. Same with that part. So this is where it gets pretty cool. So even though like the bottom of this is over here, these are still closer than those ones. So now, so we got our line, or in other words, distance coming out of here. So this is where we do some interesting colorization. So what we can do is, again, we probably want to represent these points or these planting zones by something relatable. So I can think that a circle is pretty close representation to a tree. So let's go ahead and make a circle at each one of these points. All right. And we could even, so we could give it like a color classification and a size classification. Exactly. Ooh.
Like tall plants, like with vigorous growth.
Now we're talking.
Now we're talking like data visualization that is related to the actual thing that we're trying to.
Yep.
It's becoming more visual.
Right.
As opposed to just data.
Mm-hmm. So it's all going to be based off, again, this distance. So let's figure out our like a decent radius for these. So 15's a little big. That one's, they aren't overlapping that way. So we know 8's probably the highest. Let's do like 2 as the lowest. So 8 and 2. So the first thing we're going to do is create the size of our circles. Oops. So we need to remap those values. We're going to construct. So again, if it's close, we actually want it to be large. And if it's further away, we want it to be small. So now this becomes our new values. We could probably even increase those a little bit more. So we know the large ones are really like, that's pretty accurate, I would say. Even if they aren't near, they're getting further away. Same with, like, that's a really kind of cool collection right there. And so we've got our sizes. I'm going to also do a similar thing of, like Val alluded to, like again, color is probably the last one you want to do. So we want to now give these their own distinct height. So I'm going to move this geometry. I'm going to try and avoid extruding just because it's going to require a lot of processing power, but I could essentially do, so in one of the examples, it could be like this interesting colored disc that's floating at a certain height based off of the trees. It's kind of like an abstract vegetation comparison. So we'll do Z. And we're going to use that same distance one. So everything's corresponding to that. We're just going to remap. So now we probably want it to go a decent height. So let's do something a little bit higher than 10. That starts to give us some, let's say there's no, like, could do 5 and 20. So I'm going to actually turn this off. So now they've got some height. And we could do a simple curve to compare, just act as like the stem, so to speak. I'm going to do an area for this one. And do, so here's our disk. Here's our other one. Curve, point. So there's your height for these. So you can see again, like the ones that are closer are taller and healthier. And then now we can actually give them a solid surface. And then we can actually colorize them based off of the same parameters. Like we really probably don't have to even remap much of that. I'm just going to take one of these values. It, again, doesn't really matter. All right, let's do, so distance, math, deconstruct these bounds. Let's change. So if it's close, it's green. If it's far, it's bad. And here we go. So green, healthy plants based off of its moisture needs. Red, dry.
almost feels like we're choosing backwards, like the trees that are supposed to be back, because they don't have limit on water.
Say that again?
It almost feels like the water should be reversed, because like the plants that are growing right by the water is because they're like more dependent on moisture than the ones that are farther away, right?
You could definitely do it that way. It's, I guess, all in terms of how you want to classify that. I guess I think we set the first parameters like these ones are healthy because they want moisture and they
But
want.
like they're all healthy, because they're all growing. It's just a matter of like what conditions are necessary in order for that plant to grow. Sorry.
No, I mean that's yeah. It's, I guess, all in terms of how you want to frame it, right? Like if you want to do it that way, then yes, you can.
Maybe the way to think of it would be that like when it's like that, that's kind of a map that shows you where plants might thrive
Yeah.
versus where they might just survive.
Like if this is an empty site where there's no trees, you want to.
I guess assuming that's all it's species.
Yes, we're just looking
Yeah.
for like, or maybe it's multiple species, but they're all species that like north facing slopes with lots of water.
Gotcha, that makes sense.
So I mean, let's see how rigorous this gets. So let's say now we want to look at the other soil group.
Oh yeah, but that also has soil root there.
So now, I mean, that actually processed it pretty quickly without an issue. Like, here's that group, here's that group. Like, so there's not a lot in this area that prefer those conditions. There's a lot more in that area. Then we can do the same thing where we change. Ooh, that's cool. So there's a lot that are facing east, right? Because it is kind of in that downward slope.
So this is just, now we have moisture loving plants that like different
Aspects or something. Yeah.
So this only works if you know enough about.
Yeah, exactly. Like that's not saying there's all these different planting conditions. You have to know, like in that ecoregion, like it's probably best to figure out like what type of species can grow here first, and then you start to classify them by their lighting needs, their moisture needs, and even other ones. So.
Which I think is stuff that we always, or that we already tend to do when we're doing planting plans. But this just allows us to do really nuanced level.
Right.
If you want to work with existing contours, but as you were showing earlier, that if you have a surface that you're in the process of editing,